Hi Checkmates! AWS announced at the beginning of the year that they support VPC Ingress Routing. This feature really simplifies the integration with Checkpoint CloudGuard Gateway. So if you have existing workloads that are not protected by IPS or anti-bot, and you want full visibility and control on all ingress and egress traffic, you can now get it all in just a few simple configuration steps. And if you decide you want to roll back, it will just take you a few seconds. In the next few minutes, I will explain the theory behind the solution, followed by an A to Z demonstration, where I will show you how easy it is to deploy Checkpoint CloudGuard Gateway into your existing environment with just a few minor routing changes. So let's assume you have a VPC 10.0 Class B with 3 subnets. And this VPC has just one routing table with a default route to the Internet Gateway. One VPC, 3 subnets, and one default routing table with a static route to the Internet Gateway. Inside those subnets, there are many instances with private and public IP addresses that are only protected by AWS Security Group. Take, for example, instance webins 01. It is a security group that allows all HTTP and HTTPS traffic from the Internet and an egress rule that allows access to the Internet freely on any port. Both directions are not inspected, and malicious traffic is not blocked. In order to insert Checkpoint CloudGuard instance to protect all of the instances, I will create 2 additional subnets, external and internal. The internal will be attached to the exiting default routing group. Now I'm going to deploy the CloudGuard Gateway. It would have 2 interfaces, one connected to the external and the other connected to the internal. I will use any CloudGuard CloudFormation template that I want. It can be standalone, gateway, or cluster. You can search in Google Checkpoint CloudFormation and you will get the relevant page. I will use standalone for the demo. I will set the external interface to use the external subnet and the internal interface to use the internal subnet. While the gateway is being deployed, I will create the external routing table. I will associate the external subnet with this routing table, and I will add one static route, default route, which will route all the traffic to the Internet Gateway. I will have to wait until the CloudGuard deployment ends, and then I will connect to the Smart Console to set a policy. In the first stage, I want to allow all traffic to pass through the gateway without interfering with anything. I just want to log the traffic. And now, once the policy is installed, I can move on. Now I'm going to create the Internet Gateway routing table that will redirect incoming traffic that goes to subnet 10.0.1, 10.0.2, and 10.0.3 to the external interface of the CloudGuard Gateway. The final and most important step for this route table is to create an edge association, which will associate the Internet Gateway with this route table. The last step is to redirect the traffic that goes from the instance subnets to the Internet through the CloudGuard gateway. On the default route table, we will change the default route. This time, it will point to the CloudGuard ETH1, the CloudGuard internal interface. Let's find the public IP of one of the instances and connect it over to SSH. The connection is successful. Now I will ping from the instance to the Google DNS server. As you can see in the logs, incoming traffic is passing through the gateway. Also, outgoing traffic is passing through the gateway. Now you can continue on your own and create more restrictive traffic rules and activate threat prevention policy as needed to protect your workloads. I recommend creating a new AWS data center object so you'll be able to use tags in your policy. This means that your policy is going to be dynamic and instance IP addresses from AWS are going to propagate dynamically all of the time to the gateway. Thank you for joining us, and goodbye.